Good morning, children. How are you all this morning? Good. So, children, we have finished our lesson number 11, Reflection of Light. So, in this video, we will be discussing the exercise. So, let's begin. The first we have question number 1. Answer the following question. Explain the difference between a plane mirror, a concave mirror, and a convex mirror with respect to the type and size of the image produced. So here we need to make a table. First one is plane mirror. The type of image virtual and erect, and size same size as that of the object. Concave mirror, real and inverted as well as virtual and erect depending on the position of the object with respect to the mirror. Image will be magnified, diminished as well as same size as that of the object depending on the position of the object with respect to the mirror. Convex mirror, always virtual and erect, and the size of the image will be always diminished. The next one, describe the position of the source of light with respect to a concave mirror in torchlight, projector lamp and floodlight. Answer is first, torchlight. The source of light is placed at the focus of the mirror to obtain a parallel beam of light. Second, projector lamp. The source of light is placed at the center of the curvature of the image, and floodlight, the source of light is placed just beyond the center of curvature of the mirror to obtain bright beam of light. Why are concave mirrors used in solar devices? Concave mirror is also known as converging mirror because of its ability to focus the parallel rays at a single point anywhere on its focal plane. So this property of concave mirror is used in solar devices. So the parallel rays from the sun falling on the concave mirror of a solar device are focused at the particular point to generate a lot of heat required for the proper functioning of the device. Got it, children? Let's see the next one. Why are the mirrors fitted on the outside of the cars convex? Answer is, convex mirrors have the ability to cover wider field of view by forming diminished and virtual image of the objects. Thus, the mirrors fitted on the outside of the cars are convex so that larger view of the road can be observed by the driver sitting in the car. So now you understood, children, why is convex mirror fitted? Okay, let's see the next one. Why does obtaining the image of the sun on a paper with the help of a concave mirror burn the paper? You must have done this, children. So the answer is, the rays from the sun are parallel. When these rays falls on the concave mirror, they are converged to a single point on the focal plane of the mirror. Thus, a lot of heat is produced at that point. Now, if a paper is placed at that point to get the image of the sun, the paper gets burnt because of huge amount of heat and concentrated at that point. Understood why it is so? Okay, the next one is, if a spherical mirror breaks, what type of mirrors are the individual pieces? Now, when the spherical mirror breaks, their nature does not change. This means if a concave mirror breaks into pieces, the pieces will act as the concave mirrors only. And same happens in the case of convex mirrors. Now see the next one. Question number 2. What sign conventions are used for reflection from a spherical mirror? Now the signs and conventions are represented in the following diagrams. You need to draw these two for the concave and convex mirror. Objects are always placed to the left of the mirror. That is, light must fall on the mirror from the left to right. All distance are measured from the pole of the mirror. Distance along the direction of the incident ray are taken as positive, while distance along the direction of the reflected rays are taken as negative. Heights measured perpendicular to and above the principal axis are taken as positive, and heights measured perpendicular to and below the principal axis are taken as negative. Now we have to draw a ray diagram for the cases of the image obtained in the concave mirror as described. Now when the object is placed between focus F and the point, the pole P, so the image we have to draw like this. So what will happen is, in this case the image is formed behind the mirror. This image is virtual, erect and magnified. Let's see the next case. When the object is at the focus F, so what will happen? You need to draw this diagram. Now in this case, the image is formed at infinity. So this image is real, inverted and highly enlarged. Got it, children? So the next case is when the object is between the center of curvature C and the focus F. Now look at the picture. In this case, the image is formed behind the center of curvature. So the image is real, inverted and magnified. You need to draw this diagram as well. Next is when the object is at the center of curvature. So what will happen now? In this case, the image is formed at the center of curvature. This image is real, inverted and of the same size as the object. Got it, children? Draw this diagram also, children, in your notebook. Let's see the next case. When the object is behind the center of curvature. Now in this case, the image is formed between the focus F and the center of curvature C. So the image is real, inverted and it is diminished. Got it? Okay, the next one is when the object is at infinity. So look here, the light rays coming from infinity are parallel. When parallel lights rays are incident on the reflecting surface of a concave mirror, so they tend to meet at its focus after reflection. So in this case, the image formed at the focus and is point size. Okay. Now the next question is, which type of mirrors are used in the following? Periscope, floodlights, shaving mirror, kaleidoscope, street lights, headlamps of a car. So make a table of two columns. First column is device and the second is type of mirror. So in periscope, the type of mirror is plane mirror. Floodlights, concave mirror. Shaving mirror, it is concave mirror. Kaleidoscope, plane mirror. Street lights, convex mirror. And heads of the lamp of the car is concave mirror. Now here, children, we need to solve the examples. Okay, I have given you the notes of the solved example. Please go through the problems, read it thoroughly and solve this accordingly. When you practice these sums, children, you will be able to do the sums also. Use the mirror formula to solve these kinds of sums. You must have the knowledge of the concave mirror and convex mirror as well as the formula for mirror equation. Okay, then you will be able to solve this problem. Now here, children, 3 mirrors are created from a single sphere. Which of the following, that is pole, center of curvature, radius of curvature, principal axis, will be common to them and which will be not? So here, children, draw this diagram as shown here. And what will happen from the figure? We see that pole P is not common. Center of curvature C is common. Principal axis is not common. And the radius of curvature is common. Radius of curvature is the radius of the sphere. In the given figure, length CP is same for all the mirrors. So children, with this we have finished discussing the exercise which is present at the end of the lesson of your textbook. Hope you all must have understood this lesson, children, and the concepts have been cleared. So, see you in the next video with a new lesson. Till then, take care. Thank you, children. Bye-bye.